Okay, so let's look at the small signal analysis of JFET or midpoint analysis of JFET, or you also call it as FET amplifiers. Okay, so the first thing we'll look at is small signal analysis. So small signal models of N-type and P-type. Of N-type, if you will see, this is how we represent gate, source, drain. Similarly, P-type, you have arrow outside, no difference. Okay, so for N-type, the small signal model will look like this. So you will have a open circuit voltage VGS, positive gate, source negative. Then you have a current source GM-VGS, which is voltage dependent, this voltage dependent, and there is output resistance R0 between drain and source. This is the model we will be using most of the time. So you will memorize everything, this thing. Okay, how we represent JFET as in small signal analysis. Okay, so this is how we represent. Then for P type, the model is exactly similar. The arrow is going outside, gate, source, drain. Gate and source, there is a voltage VGS, open circuit voltage, with the gate as positive terminal. GM VGS current coming from the drain to source, and R0 is the output resistance. Okay, so this is exactly similar to this. Sometimes people represent in this fashion as well, P type. So drain is in downward position and source is in upward position. Gate is as it is. So you just take this model and flip upside down. So this is how it will look like. Gate, source, positive is gate, negative is source, VGS. Then current is going from drain to source, GM VGS, and R0 is the resistance between drain and source. So this is how you represent. Okay, so model is exactly similar. The way you show in these two cases is different. Okay, even in BJT also the models are similar, and this is how it will work. uh, just where we have their beta RE, beta IB R0, okay, instead of VGS, GM, VGS and R0. So there is no difference. Even in MOSFETs also it will work out. Okay, even in BJT, JFET, everywhere it works out. The model for N type and P type are same. Okay. Now another important point, if you have to work a FET as an amplifier, your JFET has to be in saturation region. Means you have to bias the JFET such that it will lie on saturation region. Why specifically saturation region? Because there won't be any there won't be any distortion in input signal. Okay, input signal will not have any distortion, and that's the reason we keep saturation. We keep the JFET in saturation region when you when we work it as an amplifier. Okay, so the signal get does not get distorted. The AC signal what we will apply at the output, we will get the amplified version. There won't be any clipping, there won't be any kind of non-linearity in the signal at the output. Okay, that's the reason we keep the JFET in saturation region. Okay, so we'll quickly move to the common source, common gate and common drain configurations. We'll see the midpoint analysis. Okay.